Good morning, friends. Today we are going to have an overview of object-oriented programming concepts. Let's begin. First, we'll see what are we going to learn today. We are going to learn what is object-oriented programming language, what is a class, what is an object, and what are the features of object-oriented programming language like data abstraction, data encapsulation, inheritance, polymorphism, and dynamic binding. Now, all the object-oriented programming languages, they follow these features which are listed down over here. You must have done your C++, so C++, Java, all these languages do follow the object-oriented programming concepts. So let's dive in. Now, what we have seen till now was what are procedure-oriented programming language, and we have seen in our last lecture that it is based on the top-down approach. That is, you have a main function, and from the main function we call the sub functions. So this is a top-down approach. Now, program based on procedure-oriented programming languages were difficult to manage as there was lot of dependency of one function to on another, and if the number of lines of code increases, it's difficult to handle the program. Like if you have a simple program, then it's okay, but if you have a complicated program where the number of lines of code increases more than say 1,000 lines of code, so it becomes very much difficult to debug such type of programs, like where what is dependent on what, and you have to go to that particular location and make changes if you need any changes. So a programmer had to keep a track of everything in the procedure oriented programming languages, and procedure oriented programming languages focus on function rather than the data. So there we had seen that more importance was given to the function than the data which was getting affected inside the function. So to remove all these flaws, we object oriented programming languages were brought in the picture, and the main aim of object oriented programming languages was to bind together the data and the functions that operate on them so that no other part of the code can access this data except that function. So what does this thing mean? We will just see with the help of an example. So the building block of object oriented programming language is the class. So now, as the objective of programming languages, as it says that it was introduced to bind together the data and the functions that operate on them. Okay, so what do you mean by that? We will do it with an example. Now, for example, consider a class. Now, class in a real world can be referred as an entity which has certain set of related properties and functions. So it is a user defined data type. What are the data types? Like you have got integer, float, character, string, double. These were the data types. So class is also a data type, but which has been defined by a user. So we call it as a user defined data type. And what does it hold? It holds data members and member functions which can be accessed by you and used by creating an instance of that class. Okay, now let's see an example first. Now consider this particular real-time entity called which is a car. Okay, now as the definition over here says, it's a real world entity, okay, which has certain set of related properties and functions. So we will see, consider a car which has got certain set of properties. Okay, what it has, for example, it has color, it has got mileage, it has a structure. The car, every car has a particular structure. So these are nothing but set of properties, okay, which is related to what? Related to the car. And what are the functionalities it can do? It can apply brakes and it can increase the speed. Okay, so this is a class named as car which has got set of related properties, that is color, mileage, structure, which is also called as member variables, or you can say member properties, and it has got certain functions that is called member functions, that is applying brakes and increasing the speed. Okay, now consider one more example, a student. Now student has got certain set of properties associated with it. that is name, class, address. Okay, and what are the functions which a student can perform? He can give exams, he can perform different activities in the school which is allotted to him. So a student is an example, is a class having related properties and functions. So in the computer world, this was a example what we had seen. But in the computer world, how are you going to implement this real-time entity in the form of classes? So we had seen class. Class is a keyword over here. Okay, car was just we have identified a real-world entity called as car, having certain set of properties. Which were those? The color. Again, string is a data type over here, the mileage, the structure, and these are the functions which it can perform. So if I want to implement a particular entity and I want to write it, I want to implement it in Java language or CPP language, I'm going to implement it with the help of the keyword class. Similarly, class student, we are having name, address, class, it gives exams, and he performs various activities. So this was, in this way we are implementing the real-time entity. Now what is an object? Now a class is a structure which we have declared, but the class structure won't come into existence until and unless you do not create an object of that particular structure. Okay, so what is an object? It is called as an instance of the class. What do you mean by that? That is, it possesses all the characteristics or the properties of the class. Now for example, I talk about one more, I can give you one more example called as person. Now every person has got a name, he's got an address, he's got qualification. So I declared an entity called as person, and we as like person, for example, I name few people like Ryan or say Kabir, okay, or say Kenneth. So these are the objects of the class person who has got different properties, or which has got the properties which we had mentioned in the class person. So what is as it says that it is instance of the class, so I have here this object, and the object name over here is a Creta. So Creta is what? It is an instance of the class car which has got all the properties which that particular car class had, whichever we had declared over there. Okay, similarly I have another object named as Honda City. So these are what? These are the real time implementation of the class or the structure which we had declared. The object can also perform the activities functions declared inside the class. Now, in computer world, when a class is defined, no memory is allocated, but when it is instantiated, what do you mean by that? When an object is created, memory is allocated. So what does this thing mean? Just simply declaring a class doesn't allocate that class a memory. When you actually create an object of that particular class, then a memory is allocated to that object, not to the class. Fine. Now we will see the first feature of object oriented programming languages, that is data encapsulation. Now encapsulation is defined as wrapping up of a data and information under a single unit. So what do you mean by that? I have a big box with me. I put all the data inside the box, I wrap it, and I give that box a name. So what have I done? Actually, I've encapsulated all the data under, or I bundled everything and I put it under a single unit. Now for example, consider the supposing school is my box. Okay, now what all things does a school have? It has got students, teachers are there are teaching staff in a school, there are classrooms in a school, and the admin staff is there in the school. So what is actually happening here is we have put all these informations together under a one heading, that is nothing but school. So this is an example of data encapsulation, that is wrap up the data and information under a single unit. Now the next feature is data abstraction. Now data abstraction means displaying only essential information and hiding the details. Okay. What do you mean by this? Data abstraction refers to providing only essential information about the data to the outside world, hiding the background details or implementation. Okay. Now, in this above example, it can happen that the teachers are not giving all the information to the students. Okay. Or maybe the admin staff is not giving all the information to the teachers. Whichever is relevant and which the teacher should know, only that information is shared by the admin staff to the teaching staff, okay, or the student. So what are each person doing over here, or each object is doing over here? It is hiding the data from the outside object. Okay, that is whatever it wants, it that is only will be displayed, rest all will be hidden. We'll see one more example. Now consider a man driving a car. Now, the man only knows that pressing the accelerators will increase the speed of the car, or applying brakes will stop the car. But he does not know how is the inner mechanism going to happen. Okay, that is, once I press the accelerator, how actually the speed is increasing. What is actually the dynamics of how the things are working. So a layman doesn't know all those things. He just knows that I know that these two things are there for me to accelerate and to brake. So the inner functionality is being hidden by the to the person who is driving the car. So this is nothing but abstraction. So how do we do data abstraction? Now in object oriented programming languages, we are having certain keywords which helps us to do data abstraction. Those are public, private, protected. So these are the three keywords which help us to hide the data, or we have the power in our hand that how my data will be exposed to the outside world. So we will see when we start a programming, we will see how actually these keywords are to be used. So going back, the next and a very important feature of object-oriented programming languages is inheritance. Okay, and the main what you can say importance of inheritance, or why this concept is coming to picture, is because of reusability. Okay, so that thing means a particular code which has been declared somewhere can be reused in some other in the other place, instead of again declaring it and defining it. Okay, so inheritance supports the concept of reusability. That is, when we want to create a new class and there is already a class that includes some of the code that we want, we can derive our new class from the existing class. So no need to define this whole thing again. Now there is a class, so just reuse that particular class. Okay, don't again do it right from the scratch. Okay, so for example, here I have got a class vehicle. Now the class vehicle has got these functionalities, maybe fuel amount, capacity, apply brakes. Now these are the other classes, bus, car, truck, which are actually going to use these functionalities. So instead of redefining the functionalities in these separate classes, I will just inherit. We call it as inheritance. I inherit the class vehicle inside these classes, bus, car and truck. So this is what I have done, is I have reused the data or the functions. Now there are different types of inheritance, that is single level, multi-level, multiple and hybrid. Okay, now we'll just see how does a single level inheritance looks like. So a single level inheritance, in that we have a class that is also called as a base class or a super class, and you have another subclass or a derived class which inherits from the base class. So this is a single level inheritance, one class base and you have a derived class. So a single level. In multi-level inheritance, we are having an intermediate class. That is, we have a base class which gets you have an intermediate class which gets inherited from the base class, and then again a derived class which gets inherited from the intermediate class. Okay, and these are the, in some books you can see they have used the terminologies base, derived. In some books they have used the terminology super, sub. Okay, so these are one and the same thing, only it has been referred in a different way. In multiple inheritance, we have got two different classes which get inherited from a single class. Okay, that is, I have two different, these are two different classes which get inherited from the same class. Like how we had seen in this example, these are the two different classes which get inherited from the same class. Now the hybrid inheritance is a combination of a multi-level as well as a multiple. So you can see this is a multiple, and if you see this one, this particular thing, then this looks like a multi-level. So that is a hybrid inheritance. Now Java doesn't support hybrid inheritance, neither does it support multiple inheritance. In C++, it supports all the types of inheritance, but Java doesn't support these two type of inheritance. So they have given us an alternative of packages. So there is a concept called as packages in Java, which has replaced this particular multiple inheritance and hybrid inheritance. Then the next type of or the next feature is polymorphism. Now what does polymorphism mean here? Poly means many and morphism means forms. So a single thing can have many forms. Okay. So in simple words, what does it say? We can define polymorphism as the ability of a message to be displayed in more than one form. Okay. Now I'll just see an example of it. Okay, now consider I have got a function sum which adds two numbers. Okay, again I am having a function sum which is adding three numbers. So what is happening is, here the function name is same, but the variables or the what we say is the what we are passing, okay, those are different. Okay, here we are passing two numbers, here we are passing three numbers, or I can have the same function where we are passing float values. Okay, so we are overloading the function sum. Okay, the name of the function gets overloaded and the parameters are different. Okay, so this is an example of function overloading. Okay, now a person at the same time can have different characteristics. Like a man at the same time is a father, a husband, and employee. So the same person possesses different behavior in different situations. This is called polymorphism. So a man can be a father, can be a husband, can be an employee. Okay, so he has got different characteristics. Okay, depending on the situations. This was an example of polymorphism. And how actually it is implemented in C++, that is operator overloading and function overloading. So just now we saw an example of function overloading. That is, function overloading is using a single function name to perform different types of tasks. And what is an operator overloading? The process of making an operator to exhibit different behaviors in different instances is known as operator overloading. What do you mean by that? Now we know that we are having for example, this is a code where A and B, supposing A is having some value and B is having some other value. Okay, now we know that when I do A plus B, the answer will be 30, because the plus operator over here, it is meant to add two numbers. So the numbers could be a whole number, that is an integer, or it could be decimal numbers, it could be a double, any type of numbers it can be added. But what if I, instead of this, I put a string in it. I put hello and I put world. Now we know that I cannot, the plus operator cannot add strings. Okay, so I cannot have hello world over here. Okay, or if I do, instead of a plus, I'd say minus. So that doesn't make any sense. But you want it to be done. I want that if I do something like that, then in C I should get hello world. So in this case, what we have to do, we have to write a function, okay, in which we are going to overload this operator plus, okay, where that function will, inside the function we have to write the code where it will add two strings. So this is nothing but we are overloading the operator plus over here. Fine. So that is nothing but, that thing means that is an operator overloading. The process of making an operator to exhibit different behaviors in different instances is known as operator overloading. Okay. But in Java, we do not have this concept of operator overloading. Both the concepts are heavily seen in C++, the implementation of these concepts. And the last and very important feature of object-oriented programming languages is, what do you mean by dynamic binding? Now in dynamic binding, the code to be executed in response to a function call is decided at runtime. Okay, what do you mean by at runtime? Now for example, I am your school teacher and I have given different tasks to different students inside in the class. Okay, we are organizing a function, and there are different things to be done for that function. So I have given say A, B, C, these are the students, and I have given them different tasks. Now it is, I am going to call the functions depending on the situation. Okay, so at runtime, okay, at runtime, for example, the mic is not working, so whoever is from that department, I'll quickly call that particular person. So which function to be called, it is decided at the runtime. Okay, not like, we do not have a set of tasks like how in procedure that this, after this is going to happen, after this some other things will happen. It is not like that. At runtime anything can happen, and I can call anybody depending on the situation what it is. So that is nothing but dynamic binding. That is, the code to be executed in response to the function call is decided at runtime. When actually you implement that particular code, at that time we will decide which function is to be called. So I hope you understood this example of dynamic binding. When we will actually start the coding, you will get a feel of what do you mean by dynamic binding. So these were the core features of any of the object-oriented programming languages, and all of them, they follow these features, and we will see all these features one by one as we start the programming and the implementation of these features. So I hope you understood today's session. If you have any doubts, you can get back to me, and I'm here to solve your doubts. Thank you so much. Bye.